Hey guys, normally I just put up videos of running my RC car, mainly for my own purposes. But this video I'm going to do an overview of my 1/16 scale RC rock bouncer build here, and just go over the build, all the details, and also going to cover some 3D printing strategies for 3D printing RC car parts. All right, so this is a 1/16 scale. I'm going to go ahead and show you what that measures up to, what that compares to here's a 1/24 scale SCX24. You can see the difference. That's so this is about a 16th scale versus the 24 there. I like the 1/16 scale, particularly for this rock bouncer platform. Is because of the way that the vehicle performs in terms of a scale fashion, and looking and feeling like an actual full-size rock bouncer. It's not so big that it's hard to follow around if you want to take videos and be able to control what you're doing. And it's, but it's big enough where you could fit, some nice components like oil-filled shocks, and be able to do more things with the build and customization and such. So really like this size. So what is a rock bouncer? It's basically it's like a rock crawler that's designed for higher speed and or racing. And being able to generate higher wheel speed and go over obstacles that a rock crawler normally wouldn't be able to do. And it's my favorite. I really like it. I got into it just from watching YouTube videos. There's some really cool channels out there with rock bouncer content, like Busted Knuckle Films and also Mad Ram 11. Shout out to them. But yeah, rock bouncers, a lot of fun, and I really like the platform. In terms of what makes it a rock bouncer, obviously four-wheel drive, have an open wheel design, and basically like a tube chassis like you see on this. And the better ones seem to always have, the best ones have trailing arms for the rear suspension in particular. And a lot of power, being able to generate more wheel speed than rock crawler. But also be able to crawl. So that's another thing why I really like the platform, because it will also crawl pretty well as be able to bounce and bump over obstacles at higher speed and be able to scoot around, hit some jumps and stuff. My goal with this build was to use as many 3D printed parts as possible. So I'm just going to go over everything and explain it and show it to you here. So starting with the tube chassis here, that's custom designed and 3D printed, and it includes an upper tube chassis portion, and I got a lower chassis. In terms of the drivetrain, the lower housing houses the motors, and this is a twin motor, two motor build. There's two size 130 motors in there that are mated up to Traxxas TRX4M transmissions. You can see in there, that's the TRX4M transmissions. They're a size 130 hobby grade motor, so it's the better quality size 130 motors. The motors are mounted to the TRX4M transmissions, and they're mounted on their sides. And you got a motor and transmission for the front drivetrain, and another one for the rear drivetrain here. Those are mated up to all metal drive shafts from Injora. Those are Injora drive shafts designed for the TRX4M, and those are mated up to custom designed 3D printed axle housings. You can see the front and the rear. There's ball bearings throughout, including the ball bearings in the transmission, the entire drive line through the axles all the way to the wheels. As far as the axle housings and axles, the outer housings are custom designed, 3D printed. There's heavy duty brass tubing inserts that run inside of them to reinforce them. And inside the pumpkins are TRX4M upgrade metal gears. So it's the TRX 4M metal gears that are inside these pumpkins, but everything is custom and 3D printed. Again, here's the front axle. Front axle also has the brass tubing inserts, and has basically a 3-piece design. We've got the center part, and then there's the side parts with the steering knuckle C brackets built in. In terms of wheels and tires, these are custom designed 3D printed wheels, and the tires are from Banggood. So the front bumper skid plate unit, you could see here, is custom designed to protect the servo arm and the steering linkage, Pitman arm, the steering link here, so it's protected against hits, and it's been doing a great job so far. You can see I've got one horizontal member here, and the skid plates itself goes right up to the pumpkin there, and so it doesn't really compromise ground clearance much at all. And you can see how it's connected up there to with these little links that go up to the top of the axle housing. And so yeah, that's custom designed there. It's been working out really well to protect things, and that's after a couple months of testing. You can see the wear on the skid plate. This PLA Plus material seems to be pretty good for in terms of like skid plate underbody protection, dealing with scratches but not wearing out too much, and being pretty slippery for going over rocks and such. Oops, you can see the underbody there, everything. Anyways, in terms of the suspension, just kind of show you, I think I basically got, it's a 5-link in the front and the rear. And you can see using these stainless steel links with 3D printed sheaths. We got upper and lower. You can see the mounts are designed into the axle, front axle housing there, with the shock mounts here, and directly onto the axle housing. The rear is a trailing arm design, and I feel like that's one of the keys to getting really good performance, like rock bouncer performance, as using the trailing arms. And you just get so much good sensitivity and travel and damping going on there. And so you can see the trailing arms, a custom design, 3D printed there, and they mount into the lower chassis there. But that's been working really good, this trailing arm suspension. Got these really plush oil-filled shocks. You can see how plush that is. Really plush. And the front is pretty good too. In terms of the travel, you can see this focus isn't very good, is it? It's pretty good. You definitely get a full tire height there. You see that? Very good. It's pretty good travel. There you go. You can see that's definitely over tire height. For the shocks, I'm using these oil-filled shocks from Traxxas or Latrax. There you go. It's part number 7660, and been super happy with these shocks. I'm running standard springs on the back. These are custom wound springs, a little lighter gauge in the front, and running a little lighter shock oil, 10 weight on the front. I think it's 15 or 20 weight in the back. So I recently installed a anti-sway bar for the rear. It's actually the sway bar. It's the anti-sway bar torsion bar itself. Runs inside of the chassis in this little tube here, and it mates up to these aluminum links, and I use a through bolt and nut with the slot to tighten in on the sway bar, flattened ends to fasten it. But yeah, the sway bar's been working great. Super happy with it. It really stabilizes the rear and allows the front suspension to see a little bit more action, if you will, a little more articulation by constraining the side to side travel a bit on the rear. In terms of the steering knuckles and the linkages, everything is 3D printed. And I did borrow some of the design from the original toy grade rock crawler. So I really like some of the simplicity and some of the robustness of that design. In terms of the servo, this is a AGF RC micro servo. I think it's AGF RC. That's right. And this is a fantastic servo. I've had great experiences with them. I've only had, I think, one go out on me, but just incredibly strong, and for the money, for being an inexpensive unit, it's got great performance in my experience. It's pretty fast and plenty strong for this size. And I've got it mounted to a custom-made aluminum bracket, and which mates up to the the custom mount on the front axle mount here you see. In terms of electronics, I'm running two small ESCs. I think they're 20 amp ESCs that are in this jungle of cables here. Just kind of leave it messy in there. But so there's two ESCs, one 2S battery by Blomicky. These are Blomicky 2S LiPo. I can't see the milliamp hours, but these are really good batteries, super long lasting, and have pretty good power. Super happy with this Blomicky 2S battery. Got it mounted in the front there. Got the small FlySky receiver there. And so one receiver, two separate ESCs, one for each motor. So anyway, been super happy, super stoked on this car. This rock bouncer here, and the performance, especially the durability. I posted lots of running videos and testing videos showing that, but really considering how much of this is 3D printed, I really haven't had anything break on me, and I put it through some pretty hard abuse. And so I wanted to offer up some tips and strategies for 3D printing RC car parts. It's based on my experiences with this build, so I'm going to go ahead and start talking about that. So one of the things is with 3D printed, plastic parts, they're if you're connecting them up or mounting things to them, they don't thread. Screws and bolts don't thread into it very well if for something that's going to have a lot of load on it, right? So one strategy I've used throughout this whole build is using through bolts and nylon nuts. Instead of having screws go into the material, you go through the material and you use a nylon insert lock nut. These little M22 millimeters is what I've used throughout this whole build, but you can see I've used them for the links, and just for the mounts for the motors, and for putting together the axle housings. You can see it on the rear axle housing here. So using the through bolts and the nylon lock nuts, that way you get a really secure fit and hold. So that's a tip. And also using countersunk metal, countersunk nuts, mated to regular screws with the countersunk nuts. That's what I used for the steering knuckles. It's kind of hard to show here, but I'm trying to get it in there, but you can kind of see it in there. But so you could create cavities for nuts to be sit in a countersunk in the material and have the screws fasten into them and get a really rigid hold that way. So that's like, for example, what I did here on the steering knuckles with these little M2 screws. And then that mates up to a nut that's countersunk on the other side. So kind of similar to instead of using a nylon insert, regular nylon insert nut, you could do that countersunk nut to get save space that way. Another strategy that I use throughout this build to be able to incorporate as much 3D printed parts, but also have to be as strong as possible, super durable, and is using steel and brass reinforcement. So let me tell you about how I use that on this build. So for the links, the suspension links, basically I use this 3D printed sheaths, but on the inside I use stainless steel, threaded rod. So using the 3D printed material there. And for the axle housings, I've used brass tubing inserts to reinforce the axle housings. And so the whole design is based on having these brass tube inserts that make it super strong. So those are just a couple ways you could be able to make your 3D printed parts super strong to be durable for an RC car application. So another tip I have for 3D printed RC car parts that are durable, strong, and that they hold up to the punishment, at least for this size scale, this 1/16 scale, is making sure that the parts that need to be strong are thick enough and strong enough. For the link mounts, I used 2mm thick structures here for the mounts in the design for these brackets, link mount brackets. 2mm wide. That's what I use for all the suspension link mounts. You could see all throughout the whole build, on the axle housings, on the lower chassis, on the rear, all 2mm wide. At least for this size scale, that's been super strong for this material that I'm using, and I'm using a PLA Plus. So another thing is, obviously one of the parts to break most often on RC cars is the steering knuckles. And so when designing it for 3D printed material, custom design here, you could see the steering knuckles, these I guess they're called C-bracket, part of the steering knuckle. The steering knuckle mates up with, you could see, I went with a robust design, about 3mm thick there with the material, so that it holds up to the punishment and the abuse. And the steering knuckles themselves are kind of oversized. Everything is kind of robust as I could make it there. So that's another strategy, is just making things robust and figuring out what thickness that you need, and you can do some testing to make sure that it's going to be really strong. But yeah, for things that are really redundant, that 2mm thick, at least for this, the 1/16 scale, seems great. And for things that are taking direct, huge hits, direct, large amounts of force, maybe go 3mm, like I did with the C brackets here. All right, so I'm going to talk a little bit about my design process and workflow for designing and 3D printing these RC car parts. I pretty much always start with sketches, sketching out what it is I want to design and make, and do measurements, and just showing a few examples here. Here's the one for the tube chassis, just sketching it out. Always start with that and then try to include your measurements and such. And definitely heavy use of a handy dandy micrometer to get all your measurements pretty tight and accurate. In terms of the 3D printing, in terms of the design, the CAD design, I use FreeCAD platform, FreeCAD 20.1. And there's an example you can see on my screen. I've got the front axle housing that I did there, and got the rear axle housing, and got the chassis, and the mock-up motors mounted in there and everything. Can't really rotate it with one hand, sorry about that, but you can kind of see it in there. And basically able to model everything in 3D, design, and output 3D printing files, G-code. I mean, you could get things pretty accurate and be able to get the tolerances you need, and the fitments, and make things come together. So yeah, so in terms of my 3D printer, I'd use it's a Qidi X Plus, you know, a 3D printer here. You can see, got it going on here. Really happy with this unit, and it's nice because it's got the enclosure so you could print, you know, some higher temp materials, which I haven't really got much into. But and in terms of the materials on this build, this is all PLA Plus, so it's a stronger version, more modern, stronger version of PLA Plus. My reason to believe it is as strong, maybe even stronger than ABS plastic. So it's been pretty strong. I've been putting this thing through the paces and nothing has broken. Amazingly, it's truly amazing how strong it is. And so that's what I use. I use what is it? Overture brand PLA Plus. Been working pretty good in black. Anyways, guys, hey, thanks for watching. Hopefully, if you're into RC cars or 3D printing, this might have given you some ideas. Definitely feel free to reach out, and if I could be of any help to you, and appreciate watching. Thanks.